Our next example will be another theorem, which is called the law of double negation. So this says that not A, right, with two negations in front of it is equivalent to A. So to show this in a derivation, we will have a table and let's say 15 lines. 15, just to make sure we have enough. All right. Now we're proving a theorem again, so we have no assumptions to start with. So we're going to enter this in at the bottom. So this is our goal sentence. So we're going to think about how we're going to prove this or how we would derive this. This is a biconditional. And the natural way that you would derive a biconditional is through biconditional introduction. So if you look at the biconditional introduction rule, what it says is this. You need two subderivations. One that will start with this side of the biconditional and with that side, and then one that goes in the other direction. So we'll have one starting with this and the ending about there, and then one starting with this and ending down here. Copy that, and then we label both of these assumption for biconditional introduction. Okay, now let's label that line one. Okay, let's look at this first subderivation here. Oh, note that I left a blank line in between these because, again, we've got two consecutive subderivations. We want to make sure there's a blank line in between them to make it clear that there's two of them. So this first subderivation, our goal sentence here, we're trying to get to A. And you're going to run into a problem here looking at, if you look at the rules, right, there are no rules of SD, right, that, I mean, all the rules of SD tell you how to introduce sentences that contain some particular connective. There are no rules that tell you how to introduce a sentence letter. When you're stuck, I mean, this is generally so. I mean, if your goal is a sentence letter or a negated sentence letter, but more generally, when you're stuck and you just can't see how to get the sentence that you want, if it's of a form where you just can't see how you're supposed to get a sentence of that form, um, the the usual rules that you want to default to, unless you can see, you know, you have an idea of what would be a better way to do it. Uh, the rules that you would generally go with are negation introduction and negation elimination. You assume the opposite of those of your goal sentence and try to prove a contradiction. So in this case, what we would do is we would assume not A, and then we would try to prove a contradiction. Um, See, the role with assumptions is this, and what you're always trying to do when you make an assumption is you want to make sure that you know how you're going to get rid of that assumption, right? Because whenever you make an assumption, you're introducing a new subderivation, and it doesn't. I mean, you can be able to prove whatever it is that you want, but if you're proving it while you're stuck in a subderivation, like if all you're doing is you're proving it and you're stuck in the subderivation over here, you're not over here, which is where you need to be to finish your derivation, then you're not really accomplishing anything. So you always need to know how it is that you're going to be able to get out of this subderivation, to get rid of the assumption and make use of it over here in the main derivation. Negation introduction and negation elimination, when you're stuck, are safe assumptions to make because if there was another way to get your goal sentence, then and what you've done is you've assumed the opposite of your goal sentence, then you've got a contradiction, right? You have your goal sentence and you have the negation of your goal sentence. Then you can end the negation introduction or elimination subderivation that you started off with. And all you've done is you've just added a few extra lines to your derivation. Sometimes though, and this is the case in this particular derivation, sometimes adding in that extra assumption is what you need in order to be able to finish the derivation. So sometimes that extra information is what you need to be able to do it. And other times it wasn't necessary, but it doesn't actually hurt because it only adds a couple of extra lines. So the negation assumption, the negation introduction, negation elimination assumptions are safe ones to make. If you get stuck, those are ones to go with. The ones that you don't want to go with when you get stuck are the sort of blind assumptions where you just make a completely random assumption. This, incidentally, is why in SD, whenever you make an assumption, an auxiliary assumption, you always have to write in, you have the slash, and then you write in the rule that you're going to use that assumption for. That is specifically there in order to make sure that when you make an assumption, you have already decided how you're going to end that subderivation and what role that subderivation is going to play in your derivation. If you don't know what rule you're going to put in here, then almost certainly you shouldn't be making that assumption, right? You're doing that wrong. But anyways, to come back to this, so since we just have a sentence letter here, what we're going to do is we're going to use negation elimination to get this. So we will introduce a new subderivation where we will assume not A for negation elimination. And now to end this subderivation, what we need a contradiction. We need sentences of the form Q and not Q. So we need a sentence and we need its negation. And we actually have that already. We've assumed not A here, and we've assumed not A here. So all we need to do is we need to reiterate them. So we will just reiterate not A here. This is 1R. And we will reiterate not A here. This is 2R. And if you notice, then the way that the rule is stated in the textbook, right, it has Q and then not Q. They don't actually have to go in that order. All it is that you have to have those two lines in the subderivation. So we need to use reiteration to get them both in there, but they don't have to be in that specific order. You just have to have them both there. So we're not going to use these two lines. So I'm going to delete these. This is going to be line 5. It is 2 to 4 negation elimination. We are going to enter in this scope line. And this subderivation is now done. So all we need to do now is put in this scope line. I should come up with a scope line theme music to play while I'm entering these. All right. Now the next subderivation is going to be pretty much the same as that one. Starting off with this assumption, this is just a doubly negated sentence letter, and we're just going to get it the same way. This time what we're going to do is we're going to assume not A, we're going to use negation introduction. Or we're just going to do the same thing. We're just going to reiterate these two sentence letters in. So that is 6R and 7R. We can delete that row because we won't need it. This then is, that's 7 to 9. Negation introduction. Drawing our scope lines. Now to finish the derivation, all we need to do is we just put in the line numbers here. So we just need to cite both subderivations. It's going to be 1 to 5 and 6 to 10. Just expand the row a little bit so it fits. And there we are. Now we're all done. We have derived that theorem.